Mixtures are when we take things, different molecules, and mix them together, but they're not in a chemical reaction. They're not chemically combining. They're just mixing together, right? And so there's some different ways to do that. One is what we call a solution. Solution is something like salt water, right? Where you basically take salt and you mix it with water, and if you've ever done this, you stir it up, or you can do sugar in your coffee, right? So the sugar, you mix it up and it just kind of disappears, right? It's gone. You don't see it in there anymore, but you will still taste it, right? So you'll still be able to taste that in there. So you know it's still there. It didn't just like disappear really. It just became so mixed in, it dissolved. That's called a solution. It is a homogeneous mixture composed of two or more substances. So salt water is a great example of that. A colloid is a heterogeneous mixture in which smaller particles do not settle out. So something that is like mixed in. So milk is a good example. Milk is a good example of this. So milk is typically white and you can't see through it very well, really at all. That's because there's all these particles that are suspended in there, but they don't settle out. They're not. You don't just like leave milk there and all the things are going to go to the bottom. I mean, that can happen after it spoils, but as long as it's not spoiled and it's fresh, all that stuff is mixed in there. It's called heterogeneous because it's not fully mixed and dissolved, and so you basically do have parts of it that are this and parts of it that are the watery background of it in that case. So it's not the same, but the smaller particles don't settle out. Usually in a colloid, you cannot see through it. It has a level of being opaque because of the particles that are in there. Whereas a solution is often transparent because the molecules are fully mixed in, and so they aren't interfering with light coming through. They may change a color depending on what it is, but it's not going to make it opaque. It'll still be transparent in a solution. Colloids are typically opaque, like milk. A suspension is similar to a colloid in that it's a heterogeneous mixture in which there are larger particles in there, but those particles can settle out, and so that's referred to as a suspension. So if you let that sitting for some time, or if you put it into a centrifuge or something like that, the particles will fall out of the suspension. So here is salt water. This is a solution. It's a 0.9% saline. That is a very commonly used percentage for IVs and things like that, which we'll talk about. A colloid, we talked about milk. Here's another example of the thyroid gland. So you can recognize these thyroid follicles in here. The material that's inside each of these follicles is a colloid. And so you can see, if you remember looking at these, they're not transparent. They look like there's something there. Blood is a suspension. The larger particles of blood are mostly the cells and other formed elements like cells. And so this will eventually settle out, or if you put it into a centrifuge and spin it, what will happen is the cells will settle down and you're left with the plasma, which is a solution. So the plasma up here by itself is a solution, but when you have the cells also in there, then it is a suspension. Solutions are really important in physiology, and we'll talk about these a lot. They have two major components. There is the solute and the solvent. An aqueous solution is any solution in which the solvent is water. And so here it looks like putting salt into there. What will happen is the solute will dissolve and become part of the solution, like we talked about with salt water. How well something dissolves in a solvent is called solubility. And hydrophilic are things that will dissolve in water. Lipophilic are things that will dissolve in lipid. Hydrophobic is often a synonym for lipophilic. This is important in different ways. For example, some of our vitamins are either water soluble or fat soluble. So things like vitamin C is a water soluble vitamin. Things like vitamin D is fat soluble. This can be important for your own health. Most of the water-soluble vitamins have a very low risk of long-term toxicity. So if you take high levels of vitamin C every day, as long as you're not taking such a high level every day that you're having symptoms from the actual dose you take, your body is going to flush out and get rid of most of the excess that your body didn't need. It's going to go out in your urine mostly as your body basically gets rid of all the water, the excess water that you don't need. Water-soluble vitamins will be lost that way. So you're not going to have a chronic building up of most of the water-soluble vitamins. So B vitamins, vitamin C, for example. But the fat-soluble vitamins, they stay in your body. They don't go out in the urine, and so they can accumulate in the fatty tissues of the body. Vitamin A is one that people can especially overdose on. Not so much every day, but like if they're taking it every day at kind of high levels, it will build up and build up and build up and build up, and then it can have negative impacts because it's staying in the fat tissues of the body and just getting to too high levels. Just thinking of that idea of, if a small amount of something is a good idea, a large amount of something is not necessarily better. So lipophilic vitamins, it's more important to be careful of overdose. Hydrophilic vitamins, less important to think about chronic overdosing. More about solutions. The concentration is referring to the amount of a solute per unit volume. So usually we do this per liter as our unit volume. And so looking at different ways to do that, there's different ways to measure concentration. So for example, over here, it's measuring as grams per liter. That's one way of measuring. Another way of measuring is molarity. So molarity is talking about a number of moles of a solute in the liter of a solution. So a mole has to do, I know that the definition is officially here, 6.02 times 10 to the 23rd. That's not very useful. A mole is also defined as the weight of something in grams when compared to the actual atomic weight. So if the atomic weight of, let's pick kind of an easy one, let's say oxygen. An oxygen molecule, the atomic weight is going to be 32 because it's 16 for each of the atoms. So 16, 16 is 32. If you had 32 grams of oxygen, that would be 1 mole. Okay, so that's how a mole is defined. Osmolarity is the number of particles in a liter of solution. And what this is referring to is basically you take the molarity of the substance times the number of particles. And we're going to see an example of what that looks like in just a moment. Yeah, here we go. So if you had 2 moles of glucose, glucose is a molecule. It doesn't come apart. So even when you mix that in water, each molecule of glucose is going to stay a single molecule. So there's no change. So 2 moles of glucose is also equal to 2 osmoles. Well, what happens when we have something different? So here, if we have 2 moles of sodium chloride are going to separate when they get into water. So it's going to turn into sodium ions and chloride ions. In both cases, they're fully dissolving and creating a solution, but the dissociation that happens with this ionic compound results in double the number of particles. So if we had 2 moles of sodium chloride, we now have 4 osmoles present in the solution. All right, I'm going to pause here. We'll pick this up again.